Hello and Assalamu alaikum to all panelists and viewers for my video presentation. This video is purposed to present about my final year project with a project title of Water Filtration through Xylem. My name is Ahmad Izzuddin bin Mohamad and I will be the presenter of the video. My supervisor is Puan Fauziah Muhammad Yusof. Please enjoy my video. Today's presentation is structured as follow outline. There are project summary, introduction, problem statement, objective, literature review, methodology, preliminary result, and expected result. Project summary. It is about the effective ways for providing safe drinking water that are urgently needed to reduce the global burden of waterborne disease. This study will demonstrate that plant xylem from the three different types of trees, which is a readily available, low-cost, biodegradable, and disposable material that can filter water by simple pressure-driven filtration. Approximately 3 cm3 of soapwood can filter water at a rate of several liters per day, sufficient to meet the need of one person for clean drinking water. Introduction. Water shortage has increased and has become a major problem for sustainable growth. It is projected that more than 2,000 million people will be affected by this water crisis due to population growth and climate change. Clean water essentially means water that is appropriately free from physical, chemical, and biological pollutants and may be employed for purposes such as drinking, bathing, and cooking. Drinking water protection plays an important role in establishing the standard of human life in contemporary cultures. From this view, issues with microbial contaminant in the processing and delivery of drinking water may have a direct effect on public health. Problem statement. Water shortage has grown and has become a major problem for sustainable growth. Clean water is simply water that is properly free from physical, chemical, and biological toxins that can be used for purposes such as drinking, washing, and cooking. Thus, this study will explain about the solution to the scarcity of clean water. There are several objective from this study, which is firstly it is to develop materials for water filtration, and second it is to measure the flow rate of different type of xylem in filtering water. Literature review. The scarcity of clean and safe drinking water is one of the major causes for the human death cases around the world. Among the water pollutants, the most deadly contaminant was from biological origin, which is caused by microorganisms like bacteria, virus, and protozoa. Instead, WHO, which also stated that almost 1.6 million people die annually from diarrhea. Thus, many actions including prevention of contamination, sanitation, and disinfection are necessary to effectively prevent the spread of waterborne disease. However, control of water quality at the point of use is often most effective. Popular technology for water disinfection include chlorination, filtration, UV disinfection, pasteurization, or boiling, and also ozone treatment. However, all of these treatments have their own disadvantage. Firstly, boiling is an efficient method of disinfecting water. However, the amount of fuel needed to disinfect water by boiling is many times higher than that used by a typical cooking family. UV disinfection is a promising point of use technology available but requires access to electricity and some maintenance of the UV lamp or ample sunlight. Sun filter that can remove pathogens requires a large area and knowledge of how to maintain them. Cheap household carbon-based filters are not effective in the removal of pathogens and can only to prevent cavitation. New approaches that can develop existing technology are desperately needed in this context. If we look to nature for inspiration, we find that there is a possible solution in the form of plant xylem, that is a porous material that conducts fluid in plant. Plants also develop advanced xylem tissue to bring sap from their roots to their shoots. Xylem also has evolved under competing pressure of offering minimal resistance to the ascent of sap while maintaining smaller nanoscale pores to prevent cavitation. While scientists have extensively studied plant xylem and the rise of the use of plant xylem in the sense of water filtration remains to be explored. Methodology. Firstly, it is about construction of xylem water filter. Initially, the branches of the tree are cut and the pieces are prepared using clamp that can be fixed to the part. Small suitable parts of the branch of the tree are cut into 1 inch long section and approximately 1 cm in diameter pieces. The bulk of the branch was removed and the piece was into the end of the pipe. Second, it is material selection. Xylem were obtained by cutting branch from various trees, that is mango, bougainvillea and rambutan tree, growing in area of my house. Throughout the experiment, tap water was used. Then, spray tests were conducted by dissolving dye-coloring blue and mud into tap water. Branch sections were fixed at the end of rubber tube and secured with clamp and sealed by hot glue. Fabrication of an experimental setup. A submersible pump of 20 watts in capacity is placed at the bottom of the bucket. The outlet of the pump is connected to a pressure gauge through a restriction valve. The other end of the gauge is connected to a rubber tubing at the end of which xylem is fastened. Next, it is measurement of flow rate. Approximately 10 liters of tap water was filled in the container. 60 milliliters of blue ink was dissolved in it, and the solution was made to flow through the rubber tubing by applying pressure through a pump. The pump pressure varied from 0.5 per square inch to 2.5 per square inch for each set of reading. Before measuring the flow rate, the solution in the bucket was stirred to ensure proper mixed solution. For each reading, time taken to collect 50 ml of filtrate was observed using a stopwatch. Finally, it is check filterability of xylem. 50 grams of mud was fixed in about 10 liters of tap water to obtain a turbid solution. This solution was passed through plant xylem under a constant pump pressure of 2.5 per square inch. 50 ml of filtrate was collected and carefully observed. And this is how the materials will be looks like throughout the experiment. Firstly, it is the branch is cut and it is a peel off bark. Then it will be fastened in tube, and finally it is ready to be xylem filter. Flowchart of methodology. Throughout the process, it is about the start. Secondly, it is problem identification. Then it is literature review. Next, it is equipment preparation, and at the same time, material selection, which is mango tree, bougainvillea tree, and rambutan tree. Next, it is experimental and testing. Then discussion and conclusion. Next, documentation and validation. And it is last with end. Preliminary result. In this study, there are several methods that can be used to disinfect water, which are chlorination, filtration, UV disinfection, boiling, and ozone treatment. However, for my study, I prefer to use the filtration method, that is, using xylem to get the clean water. The sample will be in 3 different types to make it more effective. The flow rate of water filtration will be measured to identify which xylem could filter efficiently. Then it is expected result. The flow of sap in plants is driven primarily by transpiration from the leaves to the atmosphere, which creates negative pressure in the xylem. Xylem systems have narrow parallel aligned ducts in a way that can survive cavitation. Woody plants that is gymnosperm are formed from a single cell known as trachite, while flowering plant that is angiosperm with xylem duct called vessel derived from multiple cells. Since angiosperm have larger xylem vessels that are more effective at conducting sap, xylem tissue constitutes a smaller fraction of the cross-section area of their trunk or branch, which is not ideal in the context of filtration. In contrast, gymnosperm have short trachite that force water to flow through its membrane, even for a small thickness of xylem tissue. That's all from me. Thank you.